Now we're going to talk about linked lists, dictionaries, and other types of collections. So a linked list on the surface looks just like a list. So you would create a list of ints, my nums equal to new list int, like this. A linked list is linked list int my nums is equal to new linked list of ints. So the way that you declare these is exactly the same. How they are stored is completely different though. A list is backed by an array. A linked list is backed by objects which are linked together by addresses. So a list, if you had a list, you would do something like my nums.add and then add the actual value. Because what it would do is it would actually go to wherever the last value in the array is, because it's backed by an array, and add the value into that position. A linked list doesn't have this concept of, okay, we have a storage location of 20 elements, we are using 10, so let's go ahead and add it into the next one. Instead, they are kind of chained together. So you can add before, first, last, or after. So add last, 42, will add an element to the end of the chain. It will now become the new last element. My nums.add first, 84, will add this to the beginning of the chain. So, and I'll try to draw this here in, well, text. This is not actually an array, but you can kind of think of it as 42 when you add last. Make this as a comment. When you add first, now this looks like 84, and there is a link to 42. When you my nums dot add, let's go ahead and add last again and add 15. And so now this will look like 84, 42, and then we have 15. And so you can add various things in there, either the beginning, the end, or you can add it in the middle. So you can say something like my nums dot add after. So add after needs a linked list node, and then you give it, sorry, I didn't mean to click off of that. It's going to come back up. After linked list node, and then it needs a linked list node for whatever your new node is. So to find a node that you want to get to, my nums.find, and this will return a linked list node and finds a first node that contains a specified value. So in this case, we'll find 42. So this will add after 42 the value 23. And so this will create basically a new node. And so after we run this, our list will look kind of like this: 84, 42, and now we will have 23 and 15. So what it's doing is it's just changing the order of this. It is, instead of 42 now pointing to 15, 42 will point to 23, and then 23 will point to 15. If you're familiar with single linked lists or doubly linked lists, this should be a pretty natural conclusion to draw from this, because really all this is just a linked list, only you don't have to create it yourself, and it is a list which effectively has two components. It has a value, which is the number, and then the second component is kind of a pointer, which C# doesn't really deal with pointers as much, but effectively it is pointing to the next memory address, which will contain the next value there. And that's really all that is for a linked list. So A linked list, if you were to store this in a list, it would look more like an array. 84, 42, 23, 15. If you needed to add a new element to it, well, your list may end up going 84, 42, 20. Well, actually, what it would do is it would allocate a new storage location for whatever size it is, and then it will populate that with the values, 84, 42, 23, 15, and then the new value 100, for instance. So a list has to do a couple of intermediary steps in order to copy values from, or in order to insert new values from one to another to add a new value, and then make it bigger, whereas a linked list just shifts the order of it and moves things around.